Okay, so this part that says this right here, d equals r times t, this is the formula, right? So we have the formula, we're solving for whatever's unknown. It's telling us the distance is 16.2, we don't know what the rate is, but we know what the time is. So if we knew what the rate was, and we knew what the time was, we can multiply and get the distance. What told us the answer? It told us what the distance is. We have something missing. We have r missing, the rate. That's unknown right now. So we combine these together. We have a variable next to a constant. We divide both sides. So 26.2 divided by 1.3 is 20.2. So we just figured out what the r is. Now, you can check yourself. We take the same 20.2 and multiply it by 1.3, and we're going to get the same answer. Any questions on the first one? Doesn't this look familiar? No? Does this look familiar? Do you understand what that's saying?
Yes.
What is this saying? What type of math is this?
Multiply.
Okay, so how do I solve it?
Divide.
Divide by what?
And
Okay, and what is x? 3?
Yeah.
So 3 times 3 equals 9?
Yeah.
Same exact thing. No different. We know an answer equals, we know time, we don't know what r is. So 1.3 times r equals 26.2. Just like 3 times x, we don't know what x is. So to get x by itself, we divide both sides by 3 because this is multiply, so we're doing inverse operation to both sides. We're doing the same thing here. 26.2 divided by 1.3, we figured out what r was. Okay, let me see thumbs up or down on this. That's everyone. I want to see whether you have this or not. Okay, all we're doing is multiplying, okay? If we're multiplying and we're trying to solve for something unknown, we're doing the inverse operation. We've been doing this for a month now, right? So we divide, there's our answer, okay? Okay, let's look at B. This actually was a problem from one of your worksheets. What this is saying is Fahrenheit equals 9 over 5 times Celsius plus 32. It's asking us to solve for C. Okay, so we're focused on solve for C. All this means is we're taking this entire equation. Let me see eyes up, please. We're taking this entire equation and we're trying to get this C by itself. How we do that is we do inverse operations and start moving things around. So looking at this equation, all I do is rewrite it. I want C by itself. So I'm going to deal with the variable last. What's the opposite of plus 32? Minus 32. So I'm going to subtract it from both sides. Then I'm going to bring down the 9 over 5. Well, I have a fraction next to a variable. How do I solve that? How do I get rid of that fraction? What's the inverse operation? Reciprocal. Very good. So we're going to take 9 over 5. We're going to flip it over. 5 over 9. That's going to cancel out. What we do to one side, we do to the other. Now, let me explain when we go to write this. Obviously, we want this added in parentheses. And the reason why we want it added in parentheses, there's not anything in front of here to multiply. Are we clear? So the fact that we don't have anything to multiply here, we take the f minus 32 and we put that in parentheses because we still have to multiply at the end of the day. We solved. We got C by itself. So let's go through that slow. Here's our formula. We just have way more variables, right? We're following all the same steps. We need C by itself. So we're going to follow our rules. We're going to work on the variable side that we're trying to solve for. We're going to do inverse operations. So we're going to do the opposite of plus 32. We're going to subtract 32 from both sides. From there, that's going to cancel out. It's going to become 9 over 5 C and f minus 32. That's a fraction next to a variable. We do the reciprocal to get rid of it. We do it to both sides. Once again, there's nothing to multiply in the front of this, so we take the parentheses and we put around f minus 32. There's our answer. So, here's the interesting thing. If we're told what Celsius is, or what Fahrenheit is, we can actually plug it in and solve for it. This is an actual formula, Jose. A real thing. Good. Good talk. Okay. So once again, the fraction does not get the parentheses. It's after it. These are our steps that are involved. We're working with the variable we're trying to solve. How did this rule change a little bit? Before we had variables on both sides, right? And before that we had variables on one side. We're always working on the variable. So now this rule comes back in a way. It's saying work on the variable side that you're trying to solve for. Do the inverse operations of both sides. Is this new? Nope. Fractions next to a variable. I'm just pointing these points out, right? You fraction next to a variable, you do the reciprocal. Fraction, the inverse of a fraction is multiplying, right? That's going to bring us to our next one, our next example. So in this problem itself, it's pretty hard to understand that, right? We got a bunch of numbers and letters at the top and letters at the bottom and letters for our answers. It wants to solve for W. So we're trying to solve for this W. This isn't a fraction, so the very first thing we're going to do is get it out of a fraction. We're going to multiply m by both sides. By doing so, it's going to cancel out. This is going to become ms. We bring down the rest of the problem. Now it's fairly easy to solve it from here because we're going to take, we want the w by itself. We're going to do the inverse operation of 10 minus e. We're going to add 10 minus e to both sides. Then we just combine this. ms plus 10e equals w. We got w by itself. We solved it. You actually want to solve problems like this because is there any real math involved?
No.
Very little math. It's really moving variables across. But our brain doesn't work that way. Our brain sees numbers and wants to solve them. Okay? When you have variables, you don't know what those numbers are. You have to have input to what those numbers are to come to a solution. Okay, any questions on this one? Do you want to go through this one more time?
Yeah.
Okay, so here's the problem, right? This part's important, right? There's our colon. It's telling us to solve for w. So we want to get w by itself. When it's in a fraction, Jose, the very first thing we want to do is get it out of a fraction. So we multiply both sides by m. What type of math is a fraction? And how do we undo it? Yep, so that's why we're multiplying m by both sides. So this becomes ms because these are multiplied by each other. We bring down the rest of the equation, w minus 10e. We do the opposite of minus 10e, which is plus 10e. We add it to the other side. So here we just combine these. We bring down the ms plus 10e. That's all on one side equals w. We got the w by itself. Okay? So all we're doing is moving variables. We did the same thing on this one, the same thing on this one, and the same thing on this one. And you guys know the steps at this point. Nothing is changing. You're working on the variable side you're trying to solve for. You're working with the variable last, and you're doing inverse operations. This one drives it home. This one's fairly easy. This is saying m minus n equals 5, solve for m. So that means we want m by itself, right? What's the opposite of minus n?
Positive.
Yeah, so we're going to add n to both sides. This is going to cancel out m equals 5 plus n. It is that easy. E, we have a fraction equals x, okay? We're going to try to solve for m. I should have wrote that down. Solve for m. So what we're going to do in this case, this is a fraction, right?
Yeah.
Okay, so we're going to multiply this by k. That's going to get m by itself. So we multiply this side by k, this side by k. Moving on the other side, we get rid of the parentheses because two variables next to each other, that means multiply. M equals xk. No math involved. Literally all you're doing is doing the inverse operation to move the variable. Let's look at this one right here. When you have a symbol, now technically we know what this symbol is. It is a number. Okay? But when we write it, we're assuming we don't know what it is. So what this is saying, Jose, is that this is another variable. This is 2 times this variable times this variable. We're trying to solve for r. So we're trying to get this r by itself. Well, this is multiply, multiply, right? So we're going to divide, divide. We're going to divide these two numbers by both sides. We're going to leave this in a fraction, c over, because that's dividing, 2, and then the pi symbol. We're done with this problem. Our answer is r equals c 2 pi. Okay, any questions? Remember, it's work on the variable side you're trying to solve for, deal with the variable last, do the inverse operations. So let's do one of these together. Don't be the one. This first problem, we're trying to solve for s. Is this problem pretty easy to do?
Yes.
Yeah. All we have to do is subtract 4r from both sides. That's it. It got the s by itself. This one right here, we're trying to solve for x, right? So we have two things going on. We need to multiply y, put it on the other side, and we need to add 2 to both sides. That's number 4. What about this one right here? Solving for m. That's a fraction, right?
For n.
Right? We're trying to solve for n. Multiply both sides by m. Multiply both sides by m. This one right here, trying to solve for k.
Well, how much is?
Or x, excuse me.
How
We don't know what m is.
Oh.
So all we're doing is moving the letter over by doing the opposite. Same thing here. We're trying to solve for z. and, or excuse me, we're trying to solve for y. So y is in a fraction, right? So we can multiply both sides by y and then divide by z. So literally what's going to happen, this y is going to come up here and this z is going to go down there. Pretty easy. Like I said, your brain plays tricks on you because there's not numbers there. Nothing new in this section. Here's an opportunity to do very well on the test. We do cover whole new material on Tuesday, a lot of vocabulary. Rates, ratios, proportions. That one we're going to spend 2 days on, and this and those two sections are what is going to consist of the midterm. Okay, flip over your handouts, please, to your notes. Let's look at the worksheet. Look at number 1. Does that look very, very similar to one of the problems we just went over?
Yeah.
Isn't it exactly like F?
Yeah.
Yes, don't be the one. Look at number 2. We're trying to solve for M, right? So we're going to subtract B from both sides. We're going to divide by X. What type of math is number 3? What's 4C? What type of math is that? Yeah, so if we're trying to undo that, we're going to divide both sides by 4, right? So that one's going to be C equals D over 4. Are you seeing the pattern? Okay. Okay, so you've got your do now. You want to finish your notes, staple it together with the worksheet. I do want you to solve number 9, but I'm not really concerned about 10, so go ahead and cross out 10. That one, I didn't want to get into circumferences because we haven't even touched it yet, so it wasn't worth going into yet.
A and B. Percent.
What's that?
Well, and also.
Yes. If you want to try them, I'll give those to you as extra credit. But we didn't really cover radiuses, and there's something different that goes on. Okay. Make things happen. You want to turn the do now in today? You want to have that worksheet done coming in tomorrow, or try to finish within class today. You have plenty of time. You only have 9 problems. Okay.